Welcome to a lesson on solving differential equations using the method of separation of variables. The technique of separation of variables involves rewriting the equation so that each variable is on one side of the equation. So x is on one side and y is on the other. If a differential equation can be solved by separation of variables, it must be in the following form. dy dx equals g of x times h of y, sometimes written p of y dy dx equals g of x. Looking at these two forms here, if we multiply this equation here by 1 over h of y, and let this function equal p of y, then these two equations would be equivalent. But again, the main idea here is that we want the x's on one side and y's on the other in this form here. If we can do this, then we can integrate and find the solution to the differential equation. So let's take a look at our examples. Again, first we want the x's on one side and y's on the other. So if we add e to the power of 3x dy on both sides, we would have dx equals positive e to the power of 3x dy, but we don't want this x on the right side, so now we can divide both sides of the equation by e to the power of 3x. On the left side, we're going to go ahead and move this up into the numerator, which remember is going to change the sign of the exponent. So we'll have e to the power of negative 3x dx must equal, this simplifies to 1, so we have dy or 1 dy. Now that we have the x's on one side and y's on the other, we can now integrate both sides. So we'd have the integral of e to the power of negative 3x dx must equal the integral of 1 dy. To integrate the left side here, we're going to have to perform u substitution, where u is going to be equal to negative 3x, so differential u is going to be negative 3 dx. So if we divide both sides by negative 3, we know that negative 1/3 du is equal to dx. So if we write this in terms of u now, we're going to have negative 1/3 times the integral of e to the u du equals the integral of 1 dy. Let's go ahead and finish this up here. So here we're going to have negative 1/3 e to the u, which is negative 3x, plus our constant of integration equals the integral of 1 dy, which would just be y. We'd also have a constant here, but we'll go ahead and assume that the two constants are represented by this constant here. So now we have our explicit solution. We know that y is going to be equal to negative 1/3 times e raised to the power of negative 3x plus c. Let's take a look at another example. Again, first we want to have the x's on one side and y's on the other. We could start by writing this in differential form, meaning differential y must be equal to the quantity y plus 1 divided by x times dx. And now to eliminate the y's on the right side, we can multiply both sides of the equation by 1 divided by the quantity y plus 1. Notice how this would simplify to 1. So on the right side, we're going to have 1 divided by the quantity y plus 1 dy equals 1 over x dx. Now that we have y is on one side and x is on the other, we can now integrate. Well, the integral of 1 divided by the quantity y plus 1 with respect to y would be the natural log of y plus 1 plus a constant, which we'll put on the other side, equals the integral of 1 over x with respect to x is natural log x plus c. Now this is our solution, but normally you won't see it left in this form. If this equation is true, then e raised to this power must equal e raised to this power. And in this form we can apply properties of logarithms to simplify this further. Remember, if this base and this base are the same, the left side simplifies nicely to y plus 1. And on the right side, notice how we have some addition here. Remember, we add exponents when we're multiplying and the bases are the same. So this is equivalent to e raised to the power of natural log x times e raised to the power of c. So this is going to simplify nicely to x, and this is just going to be times e to the c. But if c is a constant, e to the c is also a constant. So we'll let e to the c equals c sub 1. So now we can write this as y plus 1 equals c sub 1 times x. Subtract 1 on both sides. And we have our solution, y equals c sub 1 x minus 1. Okay, I think we have time for one more example. And again, our first step is to have x's on one side and y's on the other. This one's going to take a little bit of work to do that. Looking at this quantity here, notice how there is a common factor of y. So let's go ahead and factor this. We'll have y times the quantity 4 plus x squared times dy minus, this has a common factor of x. Let's factor x out. So we'll have minus x times the quantity 2 plus y squared dx equals 0. So we'll have y times the quantity 4 plus x squared dy equals x times the quantity 2 plus y squared dx. Notice how this quantity contains y's and this quantity contains x's. So we're going to divide both sides by the quantity 4 plus x squared and also divide both sides by the quantity 2 plus y squared. If we do this, we would have y divided by the quantity 2 plus y squared dy equals x divided by the quantity 4 plus x squared dx. And now notice that we have y's on the left, x's on the right, so now we can integrate. Now both of these integrals are going to require u substitution. Here we're going to have u equals the quantity 2 plus y squared, so that means differential u is going to be 2y dy. Notice how our integral contains y dy, so we'll divide both sides by 2. So y dy is going to be equal to 1/2 du. Here we'll use v instead of u, so if we let v equal to the denominator 4 plus x squared, we'll have a similar outcome. dv is going to equal 2x dx, but we only have an x dx in our integrand, so we'll divide both sides by 2. So x dx is equal to 1/2 dv. So this first integral is going to be 1/2 times the integral of 1 over u du. This integral here is going to be 1/2 times the integral of 1 over v dv. So here we'll have 1/2 times the natural log of u. Remember, u is equal to 2 plus y squared plus a constant, which we'll put on the other side, equals 1/2 times the natural log of v, where v is 4 plus x squared, plus c. Now let's go ahead and multiply through by 2 to eliminate the fractions. And we'll just let 2 times c equal c sub 1. So we'll have natural log of the quantity 2 plus y squared equals natural log of the quantity 4 plus x squared plus c sub 1. And now again, we're not going to leave it in this form. If this equation is true, then e raised to the power on the left must equal e raised to the power on the right. And now we can use the properties of logarithms here. Again, since this base and this base are the same, as well as this base and this base, these are going to simplify nicely. So on the right side, we'll have 2 plus y squared equals, but now on the right side, because of this plus sign here, this is going to be equal to the quantity 4 plus x squared times e raised to the power of c sub 1. But again, this is another constant, so we'll let e sub c sub 1 equal c sub 2. So we'll have 2 plus y squared equals c sub 2 times the quantity 4 plus x squared. Let's finish this on the next slide. So now we'll go ahead and clear the parentheses by distributing here, and then subtract 2 on both sides. So we'll have y squared equals 4c sub 2 plus c sub 2x squared, and then also minus 2, because we subtracted 2 on both sides. But for the last step, notice that 4 times c sub 2 minus 2 is going to be another constant. So let's let c sub 3 equal 4 times c sub 2 minus 2. So now we have y squared equals c sub 2 times x squared, and then plus c sub 3. I think we'll go ahead and leave this as an implicit solution. Okay, we'll take a look at some more examples in the next few videos. Hope you found this helpful.